This is a tutorial for Regents Review number 30. In the first question, they're talking about a runner from South Africa who ran 400 meters in 43.03 seconds to set a world record. Which calculation would determine his average speed in miles per hour? So we're noticing the units we want are miles per hour. And the units we're starting with is meters per second, as noticed in each multiple choice option. What we want to do is look for units in the numerator that cancel with units in the denominator, like this. Units in the denominator do not cancel with other units in the denominator. You'll notice that the only one that has only 2 units left, see this has 1, 2, 3, 4, 5, 6 units left, so it can't be right. This one has 1, 2, 3, 4 units left, so it can't be right. Only this one here has miles per hour remaining. Number 2. When solving this equation, Laura wrote this as her first step. Which property justifies Laura's first step? Well, if we start with 4x squared minus 16 equals 0, but then all of a sudden, in our next step, we have 4x squared equals 16, what happened? Well, it looks like the 16 is no longer on the left, but is over there on the right. You'll notice the 16 also has different signs. That happens from using an inverse operation or a property of equality to move it to the other side. If we had added 16 to both sides, it would result in the 0 that we got here and the positive 16 that we got there. So the addition property of equality was used. The equation of a line that passes through the point 3, 7 and has a slope of 2 can be found by using the point-slope formula. This can be found on the reference sheet. For us, the slope is 2, and the x1 and y1 points are 3 and 7. These parts of the formula are permanent and always remain the same. Now let's put in the values that we know. The slope is 2, x1 is 3, y1 is 7. So we can match this now to our answer choices. Question number 4 asks you to find the solution to this inequality. Now this problem can be solved in many ways, but most of us will start by distributing on the right-hand side here, rewriting the left, and this would be equal to 6m plus 12. Now there are multiple correct math moves from here. I'm going to choose to move my letter m to the left by subtracting 6m from both sides, but you could do something different. When I rewrite, it results in negative 4m minus 4 is less than or equal to 12. Now I'm going to use the addition property of equality to move my constant to the right. And now when I use my division property of equality, since I'm dividing by a negative value, I need to reverse the order of the inequality symbol, leaving me with greater than or equal to negative 4. M is greater than or equal to negative 4. Don't forget to reverse the order when you multiply or divide by a negative. For this one here, we're looking at a sequence. Again, the sequence formulas can be found on your reference sheet. For us here, it looks like it's arithmetic, where the pattern, or the d value, the difference, the common difference, is decreasing by 3 each time. On your reference sheet, you will find this formula. A1 is the answer in the first position. So for us, that's going to be a negative 2. And the common difference for us is negative 3. The quantity n minus 1 will remain the same. So we're looking for something that has an A1 of -2 and has a common difference of -3. Oops, I forgot my plus sign here. And that gives us option number 2. Number 5. What is the y-intercept of the line that passes through these points? There's 2 ways to solve this. You can use a formula, or you can use your TI-84. The formula first would be to find the slope, then use the point slope formula. So the slope would be y2 minus y1 over x2 minus x1, leaving us with -6/3 or -2. I can use any point in the x1, y1, so I'll use this first one. So y minus 5 is equal to -2 for the slope and x minus -1. This will result in a positive 1 here. Y minus 5 equals -2x minus 2, and then y equals -2x plus 3. So the y-intercept will be 3. Now let's take a look at how we could have done this on the TI-84. When you open the TI-84 and you click the Stat button, you can edit your list of data. For us, we have 2 points. -1, 5, that's my first point, and my second point is 2, -1. Now that my points are in place, I can go back to the Stat button, and I can move over to the right to the Calc menu. And here, I want to calculate the linear regression line. They told us it was a line, so I can use linear regression. Press Enter 5 times, and there are my slope and y-intercept values. No work needed. For this example, you're asked to write the equation for the sequence shown. So the first thing you need to decide is if this has a common difference or a common ratio. If it has a common difference, then it's arithmetic. If it has a common ratio, then it's geometric. And how you can decide is by taking the second value, -12, and subtracting the first value, -27, to see what you get. Once we compute that difference, we go on to the next value, 3 minus -12, and 18 minus 3. If we get the same number every time, then that's our common difference. So this has a common difference of 15, and it's arithmetic. So we look at our reference sheet, and we find this formula to help us fill in the correct values. So the equation is a sub n is equal to the first value, which for us is -27, plus the common difference, which is 15, and n minus 1 remains the same. That would be your final answer. Question number 8 asks you to graph the inequality on the axes shown. Well, to graph, it needs to be in slope-intercept form. So I'm going to subtract 2x from both sides, giving me y is greater than -2x plus 1. Now you can use your graphing calculator to create a table of values by typing -2x plus 1 and then looking at the table so that you can get some points along the boundary line. Or you can use the slope and y-intercept shortcut. So if the slope is -2, then the slope is -2 over 1. If the constant is 1, that means the y-intercept is 1. From each point, I'm going to have a change in y of -2 and a change in x of +1. Down 2 over 1, down 2 over 1, and on and such on. You can repeat this and reverse this to get some points in the other direction as well. Now before you connect your points here to make a line, decide what type of boundary you have. Is it solid or is it dashed? So for us, it's going to be dashed because it's a greater than sign. You can simply put arrows on the end, or you can make these little hash marks in between the points like that. Now we have to indicate which way we're going to shade. And when you're greater than, you shade up. So remember, if you're a little stick person and you're walking along this line, up would be above your head. So now we know where that zone is. It would be in this area here. So we use these little straight lines to shade the solution area. That means any possible solution would be in this shaded region, but not any point along this boundary line. Number 9. The third term in arithmetic sequence is 10, and the fifth term is 26. If the first term is a sub 1, which is the equation for the nth term? Again, we know the third, and we know the fifth. So we know that it's arithmetic, and we see that 10 is getting larger, so that must mean it has an adding pattern. So what number do we have to add twice to get to 26? So it looks like it's a total difference of 16, but we need to get there in 2 jumps. So that must mean that each time we're going to add 8. So 8 is our common difference. So a sub n is equal to whatever a sub 1 is, plus 8 times n minus 1. It might help you to work this pattern backwards. If we're subtracting 8, this would be a 2, and if we're subtracting 8, this would be a negative 6. Now that I have my formula here, I can rearrange it. So I can distribute the 8 to the n and the 8 to the minus 1. And now I can combine like terms, leaving me with 8n minus 14. And now I can find the right match. When solving an equation, sometimes the fastest technique is to remove all of the denominators. I have a 3, a 6, and a 6. So their least common multiple is 6. So I'm going to multiply each term by 6. When doing that, I can reduce first and multiply second. Now don't forget, whatever's left over here is multiplying the entire numerator. I'm going to distribute first. I'm going to combine like terms second. I'm going to use the addition property of equality on both sides here. And then I'm going to use the division property of equality. And the multiplicative inverse leaves me with x is equal to 4. If you have time, you should use a check step. That is when you rewrite your original equation and you erase and replace your variable with your found value. So we're going to say 2/3 plus 1/6 is equal to 5/6. And 2/3 can be renamed to 4/6. So 4/6 plus 1/6 is 5/6. Question number 11 asks you which point is not on the graph represented by this equation. So you can show your work, or you can use a TI-84. By showing your work, you're going to guess and check using the answer choices. And in order to do that, you would erase each x and y value, and you would replace them with one of these ordered pairs. So each time, you're going to erase and replace the right value. So for this one, if I'm checking it, -6 is the x, but 12 is the y. And then I can compute. Another way that you can check is to turn your calculator on, enter into the y equals button, clear out any old work that you have, and type the equation in. X squared plus 3x minus 6. Now I simply look at the table of values and scroll up and down to check these points. I see -6 in my table, matches with 12. -4 matches with -2. +2 matches with 4. But 3 doesn't match with -6. So this is not a point on this graph. Number 12. They give you the volume formula for a large can of tuna fish. Volume equals pi r squared h. They ask you to write an equation to find r in terms of s, v, and h. So the first thing that I'm going to do is I'm going to divide both sides by pi and h to isolate, as much as I can, the letter r. The only way to get rid of an exponent is to use a root. So now r is equal to the square root of v divided by pi h. The second question asked me to determine the diameter to the nearest inch of a large can of tuna that has a volume of 66 cubic inches and a height of 3.3. Well, now that I have rearranged this formula, I can use it to erase the v value and replace it with 66, and erase the h value and replace it with 3.3. I'm going to use my calculator to compute this math by going to my main math screen, pressing the second blue key and the x squared button to get my square root value, pressing the alpha y equals button to get my fraction. I'm going to type 66, and then over here I'm going to use the pi symbol, which is the blue button, and then the exponent key right above the division sign over here. I'm going to multiply that by 3.3 and press enter. Now, because a radius is only half of a diameter, I'm going to take this answer and times it by 2. So 5.04, they're asking us to round to nearest inch. So, since the radius is approximately 2.5, then the diameter is approximately 5 inches. Because the diameter is twice the radius. Let's solve this inequality here. You could subtract 4/9 x from both sides. You could also subtract x from both sides. Or you could multiply everybody by 9 so you no longer have any fractions. 18 plus 4x is greater than or equal to 36 plus 9x. Now I'm going to subtract 9x from both sides because I like my x's on the left. 18 minus 5x is greater than or equal to 36. Subtract 18. Negative 5x is greater than or equal to 18. Divide both sides by negative 5. And now we need to reverse the order because we divided by a negative. So x is less than or equal to negative 18/5. No need to convert it to a decimal. Definitely not a mixed number. We're going to leave it as this exact value. And that concludes homework number 9.